All right, welcome back, nerds. Today, we have a really short lesson. Now, for this, I don't think I'm going to make you guys do any physical problems today. Like, we're just going to look at a few properties real quick. But my guess is that you're going to have, for the most part, a natural inclination to what these are going to do. Your intuition is going to be good for these first few. So, we're only going to do a little tiny sliver of 5.4 today. Then we're going to just switch gears and we're going to jump to the quiz. Cool. So looking at this, today in 5.4, we are going to begin talking about some basic properties of integrals. Now, for these, I just want to see how intuitive they are. They're really theorems, just so you guys know. We're not going to prove them, but they are theorems. But I just want to see what you guys think happens. So I'm going to switch color for each of these. The first of these, I'm pretty sure we've already used, and we might have written it down, but I want to verify that we have. Even if we have, it won't hurt to write it down again. If I wanted to do the integral of a sum, the integral of a sum. Now, before I even write it, anybody think they can tell me the second half of this statement? The integral of a sum is the sum of the integrals. Like, it's the same language that we've used over and over. So let's see what that looks like. And you guys are right, just so you know. First thing that I care about, though, is if I'm trying to write the integral of a sum, here's an integral. What's the sum that I put inside of here? And ooh, love it. I heard f of x, I'm going to call it. What else should I do? One more time. Subscript y. So you could do f sub 1, like you could use f subscript to differentiate functions. But if one function is named f, is there a more natural choice for the second one? G. So whether it's, I'm going to write plus with the understanding that subtracting is just adding a negative, so subtraction is covered here. If I have the integral of from a to b of f of x plus or minus g of x with respect to x, what's your gut say this should be? With the fact that the integral of a sum is the sum of the integrals, what should I write here? The integral from a to b of f of x dx plus, what was the other part of that, Sean? Good. So the only thing that you didn't give me, I didn't write. Good. Like, and I wanted to assume that you would use the same thing, but the bounds don't change. Does this seem unreasonable to you guys? Now, graphically, it's a little bit harder to see because when you think of f plus g, it's not just working on the intervals that we could do like a to c and c to b like we did on the other one, but similar ideas happen. Do you feel as though if you needed to, you could apply this? Guess we'll find out based on the one person kind of nodding at me. Deal. All right, let's take another one. This one, I'm going to hold the name for a second. What if I wanted to take the integral from a to b of some number k times f of x? Have we ever had some number k times something? And I could use c, or I just don't want to use c because it looks like antiderivative stuff. It's a constant, right? And in pretty much every other situation that we have a constant, whether it's a limit or a derivative, where can that constant move? Outside. So what do you think I should write here? K times the, I don't know why that k came out so wonky. K times the integral from a to b of f of x dx. And Sean, I love that I heard you say the word. I've left the name here, right? What do you think we just defined? Ooh, I heard constant. There's one more word that I want, though. What's this constant doing to f of x? Multiplying. Let's go constant multiple. Just like we did with derivatives and limits, constant multiples can move out front. And there are situations where this is going to be super valuable to use. Should we look at one really quick one of this? Like, and I don't want to do the whole problem necessarily, but we're going to check real quick. I assume that you guys have some antiderivatives in your head already. How many of you guys think that I did not write the derivative version of it like we could have? How would it have gone if I'd had written just here's the 23 that I want you to know, So for some people it would have gone okay, others maybe not. As a quick EG of this, entirely up to you if you want to write it. I just want to write something here. We're not going to actually evaluate the integral. I just want to see this property at work. If I wanted to do this, the integral from 0 to 1, and here's EG. What's EG short for? It's like an example is what I want. Like, I'm okay if you think about that. I know it's Latin. Exempli gratia is what it is. For example, that's what this is. Highlighting it. Okay, if I wanted to do the integral from 0 to 1 of 5 over 1 plus x squared dx. And again, we are not fully calculating out this integral right now, but here's what I really want to check. Is there a constant multiple here? What's the constant multiple? 5. Okay, second thing, I'm going to take the constant multiple out. So here it is, still the integral from 0 to 1. And then inside, I just have 1 over 1 plus x squared dx. Now, for this, most of you guys are writing this EG, and I'm cool with that. I want you to be very aware, this is a common place to put dx, but it's also fairly common to see people just do this, to just move it upstairs. Both of them are valid. I prefer this one right now, at least for you guys. Later, we'll switch to the other one. Anybody recognize this? This is arctangent. So if we wanted to do this, I'm not going to do the fundamental theorem, but this is 5 times the arctangent of x from 0 to 1. It's harder to see that this is 5 arctangent here. People can do it, and you will be able to do that eventually. But by taking this 5 out and making it look exactly like the arctangent shows up in our best friend on 364, these problems get a little bit easier if we use it. Cool with that? Okay. We've already done this one, but let's see if we can make sure that we truly understand it. For this one, I'm just going to put I'm going to leave a blank space, and I'm not going to, I'm just going to name it. Adding pieces. And I know exactly where we saw this one. We've never formally used it. Maybe. You remember last week we did the integral from negative x to x squared, and I asked you guys to take the derivative of it? Something like that? Negative x to something. It was last Friday. I can see it on the board back there if you guys want to look. Negative x to 2x of 2t plus 1. That was over the weekend problem. Anybody recall how we split it up when we came into class? Instead of going negative x to 2x, we split it up. What's between negative x and 2x? Guaranteed. 0. So we could go negative x to 0 and 0 to 2x, right? What if, for this one, we'll just say let C, and I'm not even going to say C, we're going to say let A be less than C is less than B. So all that this says, can somebody give this to me in layperson terms? So we're going to pause for a second. Rather than just reading me this inequality, I want you to tell me in human language rather than mathematics language, what does this mean? I'm going to give you like 20 seconds with your neighbors to talk it out. This does not show on the video because I paused it, but I want people watching this video to know that I asked that question. I got a lot of blank looks. I paused it, took 2 steps, and then I heard every group saying the answer, which I just want to reiterate. If everybody knows the answer when I ask it, you could say it. I'm cool with it. And what was the simplified statement of this? C is between A and B. That's it. So with that in mind, if I wanted to or needed to take the integral from A to B of f of x dx, could we split this up into 2 smaller pieces with knowing that C is somewhere between A and B? What was one of the smaller pieces, the first piece, Ralph? A to where? C. Did you know that before Sean whispered it? Okay. Like, you're okay, like, Sean, I don't want to reprimand, like, you're not being reprimanded at all. I like that you know the answer. But I like to know who doesn't know the answer as well. Like, that's equally important. What's the second part of this? Mickey. What do you think the second part is if I know that C is between A and B? So we've gone from, like, and you don't have to have the number line, but I just want to think about what's happened. We're going from A to B, and we claim that somewhere in here is C. So just now we went from here to here. Where's the next part I need to cover? Love it. C to B. Okay, we've looked at that property. I don't know that we formally wrote it down like this, but it's just a little bit formalized here. Okay, there's one more that we're going to see, and we're going to use a picture to help make sense of this one. Any questions on the first three before we move on? Okay. Last one feels green to me. We're going to draw a picture. So looking at this, we'll name this, and it's going to be called bounds. Bounds. And I don't think they actually named this, but this is what makes sense to me. So looking at this, there's a few more little pieces that we would have to be mindful of, but I'm going to sketch my graph, and it's going to be a single graph. Let's go from A to B here. Now, if I wanted to, and assuming that we have a nice function, I'm going to use really ugly language, but we're going to make sense of it. We're not going to write the ugliness. If I assume that this function is monotonic up, mono meaning what? One. Tonic, I don't know the exact translation, but we're going to think of it like direction. It goes one direction and it goes up. Is my function increasing or decreasing, do you think? Increasing, and it's always increasing. If we say it's one direction and it's always up, it never switches directions. So whether it's monotonic up or down could vary this, but let's work with one that's monotonic up, something that's always increasing. And it can get faster and slower, that's okay, but it is always increasing. Okay, for this, there are two really, really, really rough estimates that we could get for this area. And I guarantee that we could find an area that's too small and probably an area that's too big, that with one single nice picture. So if we look at this, I don't know how I'd suggest you guys do this. Maybe shade differently in your stuff. You can also come up and get colored pencil if you'd like, because I'm going to use colors with this. Could I estimate the area really poorly using this? Where maybe, and why would I call this bounds? Why is that what I've used for the theorem? I'm using the left boundary, right? Let's just say that this height, whatever it is, we'll call it little m. And I could find this area, and it's, in this particular picture, it's way too small, right? Now, for this, if I wanted this actual area, it's way smaller than the real area of the integral. Do we agree with that? Because I can see all this stuff that I'm missing. Which means that if I wanted to calculate the area from this specifically, how would we find the area of this with what's written on the board? Good. I'm going to change the order, but I agree with you. Abigail says m times b minus a, because it's a height of m, lowercase m, and a width of b minus a. Do we all agree with that? Now, I guarantee that this is less than or equal to the real area, like the actual area that exists here. I'm going to call it true or real. Either one is fine with me. The or equal part is not clear here, but if I had a function that just did this and it wasn't monotonic up or down, but it was just a constant, I would see that it is the actual area. Okay. Is there another bound that I guarantee that this is going to be less than? If I use the right bound in this situation, here's the height of that rectangle, and this one, this is where the shading is going to get weird if you're shading. Let's say that this is m. I'm not going to shade this one. Is this an over or underestimate? Way over. How would you find the area of that red region? What's the height of that rectangle? Big M. And what is the width of that rectangle? B minus A. All that we say is if we have an integral and we have these values, and there's some variations of this that we're just dealing with one nice example here, but we should be able to find a small area and a big area and agree that it's somewhere in between those. Now in the constant function, it's why we use the or equal to, because it'd be the little area equals the true area equals the big area, because they're the same areas. Cool. 4 new theorems today. Any of them seem crazy? All right. So here's the deal. You're taking a quiz today. I want you to put your notes away. Cool. So for this, I'm in a pretty good mood. I went to bed super. Wish I wouldn't have just showed somebody's grades all on the video that I would like to post. We'll have to edit that. That's okay. All right. With that said, I'm going to go not to the grade book, but instead we're going to freeze the screen real quick so there's a little suspense. This I want you guys to get into your groups and work it. Leave your calculators behind. I don't want calculators on this. Here's the deal. On this, just so you guys know, multiple choice on the AP test. I do this very differently. Is that tears of sadness or joy that are about to come out of your face? It looks like you're about to cry. Are they tears of joy? Okay. Okay. For this, I need your ears open real quick. On the AP test, you are allowed to guess, and you are encouraged to guess if you don't know an answer. You have a 25% chance of guessing correctly. On this, you have a 0% chance of getting any points, whether you guess correctly or not, because I want you to show all the work that goes into your multiple choice for every one of these. Okay, we're going to try and see how long this goes. Those of you on the road, I will be sending you a PDF of this in just a moment. If we are able to finish it before class ends, that's awesome. If we don't finish it before class ends, less awesome, but this will become the first grade in our next quarter. Cool. Baller. I want you guys to work together. I'll get something up on the screen here in a couple minutes. Does anybody know if the game is on NFHS today or yesterday they weren't, they said. They said they were on Homer or Kenai Peninsula stuff. I don't know. I'll find the game. Cool.
I think it's.
Okay. I'll look. I'll have it on muted here for us. Okay. Delilah and Riley and Kalisha and Alex. I will upload or I'll email you guys all a PDF of this. You guys are encouraged to work together. Because there's a possibility that this goes home, I want you to work as much of this as you can right now without your notes. If there comes a point where you need to check your notes, I'm open to it, but I want you to really make sure you've exhausted all of the collective knowledge in your group before opening your notes. Cool, cool?